Hi, everybody. Good morning. Sorry for the delay. We are having some technical issues, but I think we're going to get started. Thank you very much for joining us. We're so glad that you're here. My name is Jessie Ma. I am a research fellow at the Center for Urban Energy at Ryerson University. Soon, hopefully, fingers crossed, if the technical issues get ironed out, I will be joined by Gary Thompson, who is the Supervisor of Engineering Standards and Technical Studies in Energy Solutions at Toronto Hydro, and he's also an honorary fellow at CUE as well. So in this session, we wanted to pay tribute to one of our founding partners, Toronto Hydro. As most of you know, CUE is an academic industry partnership. We are dedicated to finding sustainable solutions to urban energy challenges. We rely heavily on our industry partners, in particular to define the pressing energy challenges. And we, as researchers, bring our engineering, policy, economics backgrounds to solve those challenges in collaboration while maintaining our academic independence. So Toronto Hydro has been with us from the start. They've been with us for 10 years. They're one of our founding partners. Here's a list of the different projects that we've collaborated together on over the past decade. I won't go through all of them, obviously, but I just wanted to point out that there's a diverse range of topics and projects that we've worked together on. Everything from worker shoulder injuries to customer interruption costs, integration of renewable energy, and grid adequacy studies. I also wanted to highlight that there are quite a few projects that look at energy storage, and we're going to highlight two of them today as well. The first one is the large-scale battery project. This is a project that we at Ryerson worked with Electrovaya, OCE, the Ontario Centres of Excellence, and Toronto Hydro on. Back in 2012 up to 2016. This battery was 150 kilowatts with 625 kilowatt hours, so it gives approximately 4 hours at full capacity of energy. And you can see from the photos here, this is here more to give a sense of scale on how large this was. This was next to, in the parking lot next to our old office building in the middle of downtown Toronto. So it was a unique project, the first of its kind. Our role at CUE as researchers was to integrate, test, and operate a large-scale battery. The work included both exploring PNC, protection and control features, and measuring its impact on the urban distribution grid. And also through this project, students and researchers, we were involved in training students to help them prepare for entering the workforce with expertise in energy storage. So I'd like to share a video on about this project. So if you just give me a minute, I will put this through, and it'll tell us a bit more high-level background about the project.
Oh, yeah.
Oh, you're in. You're in. Okay. Bye, Gary. Thanks.
Thanks, Gary. Bye-bye.
Okay.
Great. Hi, Gary.
Good morning.
Hi, great to see you.
My apologies for the technical challenges here.
No worries, it happens. We're glad that you're here and you're right in time. So we just we were talking about the large scale battery, and we'd love to hear your thoughts and insight into some of the key outcomes for the battery project. So maybe you could start by telling us. Maybe let's start by talking about the fire department protocols that were developed for this project, because I think that was quite unique. How did this differ for this battery than for other Charman hydro equipment?
So the let's take a step back in time and realize that when this project was being done, Toronto had only one energy storage facility, and that was at the Roding Community Center. That was a community energy pad mount unit. This unit was the first, and that was in the Horseshoe. It was in North York. It was in residential, whereas this unit was in the downtown core. It was in a compact setting, high rises, busy streets, lots of pedestrians, lots of influencers, and a lot of eyes. Prior to this, there was a fire in Arizona, and that fire created concerns among the team that was putting this project together. One of the concerns was, how do we, first of all, to understand why the fire started, and to see what safety matters we could put in place to ensure that we did not have a repeat. The first part of that was to realize that monitoring on energy storage systems, even though at that time was not a big concern, had become a concern in that report. So we engineered in significant monitoring of that energy storage unit, way above and beyond anything that the industry would have required at the time. And that monitoring involved, the Ryerson University fire response protocol. It involved cameras that 24/7 monitored the physical environment of that battery energy storage system. And it also involved 24/7 monitoring of the electrical operational characteristics of the battery. The next step was, what do you do with response? What do you do with fire response? And with that, we reached out to Toronto Fire. We reached out to the fire officers at City Hall. And the response was that the crews that would respond really needed to understand what this was. Again, bear in mind, This was the second battery energy storage unit in the city of Toronto. And when we did the first one, even though the first one also had monitoring, but never at the level that this one had. And our fire protocols were considered appropriate at the time. So first thing we did was the familiarization. So we had, in over a couple of days, quite a few crews come through the facility. They were given a tour. The doors were open. They were given an introduction to battery energy storage, and they were given an introduction to what was actually in there, the materials, how it operated, and the fact that that energy storage system also had a fire retardant system that was installed. And that was considered, at the time, Toronto Fire raised no further concerns. So that familiarization, the unit was in the open, and Toronto Fire at that time considered the introduction and familiarization with the battery energy storage unit an appropriate response.
Yeah, thanks, Gary. And those protocols are things that we can take and use in future projects as well, right?
So where we are today, now that's an interesting point, Jessie, if I may comment. Mm-hmm. So we have seen a number of evolutions of that since we've come. So with more experience, so this really paved the foundation for our experience, knowledge, and response to issues of safety in energy storage going forward. So we have gone through, I would suggest, we're on our fourth iteration of that battery energy storage safety and system response. And all this has been done with the collaboration of Toronto Fire Services. And I must point out, a lot of this is experiential. Every time there is an event, whether it's a fire, whether it's a shutdown of an energy storage unit, we take great pains to look at the literature, to look at the reports, and try and ingrain that into what we do in our safety response and in our fire response protocols. And also learning from our quite knowledgeable associates at the Toronto Fire Services. So where we are today is nothing compared to where we were back in 2012, 2013 when we did this. We've moved considerably forward.
Yeah, that's great to know that Ryerson can play a small role in moving us forward in the fire safety and worker safety areas in particular. So in the interest of time, I want to move to the next project. And before we start talking about the pole-mounted energy storage system, I do want to point out to everyone that there is a Q&A portion of this window. If you have any questions, please put them in there, and we will save some time at the end to try and answer any questions you might have. But you can start thinking about them right now and start putting them in the Q&A portion of this session. That would be wonderful. So we talked about the large-scale battery storage system. Now we're going to go to one that's much smaller, this pole-mounted energy storage system that Ryerson worked on with the Ontario Ministry of Energy, eCamion, and Toronto Hydro. And this was done in 2014 to 2017, and the battery was about 15.9 kilowatt hours. So there are a couple photos of it there you can see. This project also won an award from the Canadian Electricity Association, And for this project, Q's role was to develop a smart control system, test the unit in our smart grid lab, and also field test the unit on Toronto Hydro's network. So I will share a video about this project in just a couple moments. Great. I will go back to the slides. So, Gary, I'd like to tap into your expertise on this project as well. Q's main contribution was an optimal self-scheduling software for this project, for these batteries. Can you tell us a bit more about that?
So actually, Q had quite a bit more significant role in it. So the idea of this was to demonstrate that battery energy storage could help to alleviate loads, stress on the system, could help to extend the life of assets. And how do you do this? So one would think that having an understanding of the load, of when the load occurs, is key. Understanding that, then you somehow need to link that knowledge to how the battery energy storage system operates. And that is one of the very key roles that the Center for Urban Energy played, was in developing that algorithm that looked at the loading on the system and directed the battery energy storage system to charge and discharge in accordance with how the grid required it. So this pole mount energy storage system was paired with a pole mount transformer. That transformer, the 50 kVA transformer, it was at least 20 years old, and it was approaching the point where it was fully loaded. So Toronto High, and because of age, because of its utilization, and because of the approaching load capacity, Toronto Hydro would have had to step back and now consider what needed to be done to ensure that the ratepayers who were being supplied by that transformer could have an enhanced reliability and resiliency supply. What the energy storage unit did with the direction of the Center for Urban Energy Software is that it was able to schedule discharge of the battery such that the actual load that the transformer saw was reduced. So instead of the transformer seeing an increased loading, it actually was reduced such that theoretically we could now extend the life of that transformer, the life of that asset, and we could ensure that our ratepayers continued to benefit from the investment in that transformer and in the technology to support that transformer.
You're right. I like how you touched on the more efficient utilization of the existing assets translates into more favorable rates that all ratepayers and all electricity consumers can benefit from as well. Let's talk about some of the technical standards that had to be developed for energy storage, because energy storage is very different than typical equipment that's been on Toronto Hydro system for the past century. Can you tell us a bit about some of the differences and what the work that had to go into connecting and commissioning energy storage systems and how that differs from existing equipment or typical equipment?
Sorry, Jessie, you fell off at the last part. Could you repeat that question for me, please?
I wanted to talk about technical standards that may have needed to be revisited for the purposes of energy storage, given the uniqueness of energy storage as equipment and how it differs from traditional equipment on Toronto Hydro system.
Interesting question. Now, you realize that this was a new bit of technology. So this was, so we've had experience with energy storage before, as we talked about in the last topic. But now we had to put it on a pole. So what we did is we referred back to best practices. Best practices in, and this is standard practice across, in the utility industry. How do you install a pole? It sounds simple, but there's a lot of work behind it. How do you get the right pole? The loading on the pole. So the weight of the battery energy storage unit was key in how we designed the actual mounting on the pole. So we used existing standards to support a new technology. Okay. Coming out of that, we gained significant experience in how that standard, how those existing standards, we were able to extend them to new technologies. Again, showing the flexibility of the type of work, of the type of standards and practices that Toronto Hydro has in place. It's very important to us that whatever we develop it prudently, we develop it cost effectively, and we ensure that we can get the best value. We can leverage those standards to get the best value. And that was practically what was done here. I could venture to say that physically mounting this pole-top energy storage unit was really no different from mounting a bank of three-phase pole-top transformers. So using those load calculations, using that methodology, using the support of our crews and the support of our industry partners, ECAMIN and Ryerson, we were able to get there. with experience.
Mm-hmm. Yeah, excellent. So it's a real collaborative effort.
Very much a collaborative effort.
Everybody's expertise and experience there. So that's great to know. Also, maybe we could talk a little bit about the space saving option that this pole-mounted energy storage system provides, because that's also a unique aspect for this project as well, right? It opens up a lot of options of where applications like this could be used. Could you speak a little bit about future opportunities for a project like this?
Okay, so a couple of things we realized out of this. One was that yes, battery energy storage can be applied to extend the life of assets.
Mm-hmm.
And in today's world where resources, financial and other resources are certainly not limitless, we need to seek as many opportunities as possible so that we can leverage the limited resources we have prudently. How do we do that? Through projects like this. So we have learned, yes, we can extend the life of assets using this. We learned that we can reduce the strain on the grid by using assets like this. We learned that in the emerging field of electric vehicle charging, that an asset like this can be utilized to support electric vehicle charging under the guise of reducing the strain on the system by supporting energy storage banks, electric vehicle charging facilities, such that the demand on the grid at that time, though the grid may not be in a position to supply at that particular time, the energy storage there installed can support. Bear in mind that the grid, from a supply standpoint, Toronto Hydro has no issues, no roadblocks in supplying energy. However, a key rudiment of grid operation anywhere in the world is timing. Supply and load. You need to ensure that they are together. In the case of electrical vehicle charging, because of the randomness in charging behavior, it can be a challenge when installed to determine is there sufficient energy at that particular time. And that's one of the things that the pole mount energy storage unit was able to demonstrate, that yes. So with all those in mind, we have certainly moved forward in our planning, in our engineering, and in our conceptualization of what future thoughts and applications can be in support of our supply reliability and resiliency of the grid.
Right, that's great. There was a lot of learning from this project, and we do carry it on to a project that we're working on now. So I'll just quickly touch on this before we take questions from the audience. But the collaboration between Ryerson and Toronto Hydro continues. We are currently working on a project that looks at optimal planning and scheduling of energy storage. So similar to what you just mentioned, Gary, about making sure that the energy is there when you need it, and there's a lot of uncertainty and unpredictability. What are planners and operators supposed to do to minimize risk and to make sure that the energy storage units are there when you need it? So that's
So Jessie,
go ahead.
if I may just say something.
Yeah, sure.
Energy storage systems are unique. Yes, we have had batteries in the electrical grid. Archaeologists found batteries in North Africa that date back 2,000 years. However, the current technology that we have is different in the sense that its operation, its design, its operation, its utility, its effectiveness is based on the environment, is based on how you use it. It almost has a life of its own, as compared to the mundane assets that utilities have always been accustomed to using: poles, switches, circuit breakers, fuses, lines. You put them, they have very defined states. Energy storage systems are totally different from that. So learning is key. And I must say that we have enjoyed the journey with the Center for Urban Energy, in that we have done a number of successful projects with them in this area. And as Jessie alluded to, we continue to work with them to better understand this asset. We continue to learn. It is an asset that continues to inform. Just to give you an idea of something that you can relate to out there is, in the video, we referred to cell phone batteries. We all have, at one time or another, had access to laptop computers. How those batteries operate, how those cell phone batteries operate, are very analogous to battery energy storage on the grid. You just multiply it a couple hundred times, and you can understand that how many times you charge, you discharge, how many times you use it. Is it hot? Is it cold? Is it humid? Is the load it's supplying a normal load, or is it full of harmonics? All these things contribute, and that is what makes this learning, this collaboration with Ryerson, exciting and indeed a great value add to the things that we're trying to do.
Yeah, great. And I think the journey of learning is, we at Ryerson very much appreciate going on this journey with Toronto Hydro as well, and making sure that our work is not done in ivory tower in academia. We're happy that the work that we're doing with Toronto Hydro is applied. It's useful. It's something that can be used right away, and it has value to industry and to society. So that's something that we value very much in our partnership with Toronto Hydro. So we had just a few minutes left, and I see there are a few questions that have come in through the Q&A. So thank you everyone for putting in your questions. The first question, I'm not sure which, well, this might have been for the large scale battery project. Is the storage battery under some sort of automatic control to get it turned on or off, or is it under manual control?
So let me speak to the pole mount. The pole mount unit was under automatic control, and that was the big part that Ryerson played. Ryerson developed the scheduler and programmed the controller that successfully managed the energy storage unit. Of course, like all distributed energy resources on the Toronto Hydro system, the unit was monitored 24/7, and we ensured that it operated within its safe design parameters. With respect to the unit at Ryerson, that earlier trailer unit, that unit had a level of automatic control in it, but it was also much closely monitored by Ryerson. And bear in mind that the level of technology grows with each project. The unit, what we were able to do with respect to monitoring and control with the unit in the trailer at Ryerson, what we did in the pole mount was far beyond that. What the two of them did have in common, and I must again repeat, with all distributed energy resources on the Toronto Hydro system, they are monitored 24/7 on our system control and data acquisition system, now our energy center, to ensure that they operate within the safe design parameters and that they give the full benefit of which they were designed back to the grid.
Mm-hmm. Yeah, excellent. So we had two different approaches for those two projects for monitoring.
Yes, and it was based on the timing, when it happened and what we knew.
Yeah, what we knew at the time, the application, and of course, safety was a major factor in all cases, no matter what.
Yes.
Okay, so there's a question from Dr. Bala. How will we make energy accessible to everyone in Toronto? This might not be only battery related.
How do we make energy accessible to everyone in Toronto?
Mm-hmm.
I mean, I could be quite philosophical about that. Our lives are such now. We are no longer hunters and gatherers.
Mm-hmm.
So electricity has become a central part of our very existence. Some use less, some use more, some tries to use none at all, but they have a cell phone. So, which is electricity being used. I think over its 100 and odd years, Toronto Hydro has demonstrated its desire and its intent to make electricity available to all the ratepayers in the city of Toronto. If you look back at over the 100 and odd years, we've done so reliably, we've done so efficiently, and even with the impact of significant events, we have risen above and we have quickly come back to restoring supply to customers. Having said that, we're in the age where we now begin to look at methods. We now begin to look at policies. And you all know there's a lot of work going on. There are a number of players. There's the IESO, there's Hydro One, there's Toronto Hydro, there are the stakeholder groups, of course, the City of Toronto, and we all, in a sense, operate under the umbrella of the Ontario Energy Board, who's the regulator. What are some of the issues, the influences? Conservation and demand management. How do we responsibly manage the energy that we use? How do we, and on another topic, how do we safely and reliably provide that energy that we use? And what type of energy security levels are required, not today, because when we plan, we really don't plan for today because today is here. We plan for tomorrow and the next 5, 10, 15 years. So those are areas that I think are worth dialogue, are worth discussion. I know that my good colleagues at Toronto Hydro with the other stakeholders in the system work assiduously to explore those topics and to ensure that that energy supply is available to the ratepayers of the city of Toronto. It's not an option. It's not a nice to have. I'd say that we at Toronto Hydro fully recognize the important role that we play and that we need to not do it well, but we need to do it to the best of our ability.
Great, thanks, Gary. Very well said. It's not an easy question to answer. We are at time, but if you have a couple more minutes, maybe we can take one more question since we started.
Yes, I'm here. I'm available. Yes.
Okay, excellent. So there's a question here. Since the transformers were 20 years old, what was the cost-benefit analysis, considering that efficiency of a newer transformer would have been better, and the fact that peak demand would go up by 10% year over year?
So first of all, let me address that issue about peak demand goes up 10% year after year. That's a generalization across a system. In specific areas, peak demand can go up significantly. This was one area where we were, we were seeing a generation shift. You know, I mean, one of the things that we see in Toronto is, you know, the war bungalows go down and the 5,000 square foot houses come up. That in itself is a generational shift. The transformer that feeds that war bungalow is the same transformer that's going to feed that 5,000 square foot house. So that's certainly not 10%, especially if you have that happening. You just need a couple of these in a neighborhood. Mm-hmm. And I would invite you all to, as you drive through the neighborhoods in Toronto, to see the change that's happening. Toronto, the change is not only going on downtown, it's going on in the suburbs. The other thing is, the price of a transformer is significant, but is not the significant issue here. That transformer has to be purchased. It has to be designed, built, tested, approved, purchased, stored, quality system applied, put on a pole and connected. That's what we refer to as installed cost. Installed cost is not just the cost of the transformer. So when you look at the overall cost, now you now factor in to that overall cost timing. How long will it take you to do that? How are the customers going to be impacted by not having their electricity supply? There, you know, Toronto Hydro has a responsibility to step up and ensure that the customers, in, you know, as much as possible, don't see a interruption of supply. So for that time, we'd have to put temporary resources in place to supply that energy. So that overall cost, when you look at it, can be quite significant, which is why we try to make sure that when we replace our assets, it's got to be done. It's got to be done. We try and ensure that, first of all, the assets we get are the best in the industry, are the best for the market, are the best for our ratepayers. And we try and ensure that we manage those assets to the best of our capabilities as long as we can. The longer we manage that asset in place, the better the value to the ratepayer.
Great. Thanks very much, Gary, for sharing your insights with us today. Yeah, it's been a joy and a pleasure working with Toronto Hydro over the past few years, and I hope this partnership continues, this collaboration continues, and that we can continue to work on solutions for energy storage and other urban energy challenges. Also want to thank everybody for joining us for this session. We are entering a break time, and I believe the next session starts at 11:05, where you can hear about clean energy zone startups. So I hope to see you there. Thank you again, and take care, everybody.
Thank you very much.
Yeah, thanks, Gary.
Bye-bye.
Bye.